Hello everyone, thank you for coming. My name is Chatzisofroniou, it's a little hard to spell. I work as a security engineer at Census, a Greek company that provides specialized IT security services to its customers. I'm very excited to be here today because I'm gonna present to you something that is novel and I've never presented to any conference before. It's called Lure 10. The title is Exploiting Windows Automatic Wireless Association Algorithm. What is really special about this kind of attack that I'm going to present to you is that it's part of a category of attacks called Wi-Fi Automatic Association attacks. These are very cool attacks in my opinion because they actually allow you to gain a man-in-the-middle position without requiring any user interaction. Okay? So that means that any Wi-Fi enabled device, that could be your laptop, that could be your tablet or your desktop if you have a wireless card attached, is vulnerable to these kind of attacks without requiring any interaction from the user. The only requirement is that the victim needs to be within the vicinity close to the attacker's rogue access point, okay? And as you can probably guess, there is a significant impact to this. Since there are a lot of software, most of them actually, do not carry any proactive protections against man-in-the-middle. So these kinds of attack, you gain man-in-the-middle just like that. It's very simple, okay? Does anybody know the karma attack? Please raise your hands. Nice, I see a few hands there. So in the karma attack, what is happening is that, let's say that some of you here visited the hack-in-the-box free Wi-Fi that is in the air. So as soon as you go back home, your device is gonna ask for this network again and again. Most likely this is going to happen, okay? Your mobile phone is gonna ask for this specific network. It's gonna shout to the air, hey, is hack-in-the-box free Wi-Fi here? This is called the probe request frame, this message, right? The thing is that an attacker can say, hey, yeah, here I am. I am the free Wi-Fi that you're looking for. And that's probably the standard way for the past 10 years to get a man-in-the-middle position. So as you see there on this diagram, the laptop that is top right is sending the probe request frame, and the access point is responding, yes, here I am. Here are my encryption type, transmission rates, and other information. The problem with that is that as soon as the laptop sends the probe request frame, an attacker can say, yes, no, I am the network that you are looking for. This is the karma attack. It was presented more than 10 years ago, and there are still devices that are vulnerable to this kind of attack. However, modern operating systems and network managers specifically have countermeasures against this. So, for example, Windows. Windows 10 and Windows Phone 8.1 aren't vulnerable to this attack because, first of all, when you join an open network with your Windows device, it's not going to add this network to its PNL. What is the PNL? The preferred network list. This is the list of the networks that is gonna keep asking everywhere your device is. Wherever it is, it's gonna ask for the networks that exist in the PNL. Okay? So Windows won't really add any open network that you join by default. You can manually go there and said, yes, please connect automatically to this network. But by default, it's not going to happen. That's number one countermeasure that Microsoft did. The second one has to do that you saw earlier how the mobile device is going to send the probe request frame and the access point is going to respond with a probe response frame. This shouldn't be the way that things should work. So the proper way to do it is that the access point should send the so-called beacon frame. So the beacon frame is what the access point sends to everyone, broadcasts to the air. And it's a way of the access point to say, hey, I am access point with ESSID. ESSID is the name of the network. With ESSID mumble or whatever. Here's some information about me. If there are any clients that want to connect to me, please send the probe request frame. This is the proper way, what you see there. So the access point is actually sending the beacon frame first, and then the client will actually connect, send the probe request frame, and continue with the association process. Okay, so these two countermeasures actually made Windows not vulnerable to karma attacks. So before I go to the next slide, that means, are we protected? Does that mean that there is no way to get automatic association and automatic money in the middle of Windows? Unfortunately, no, because Microsoft came with this feature called Wi-Fi Sense. Okay? So I'm going to read that to you. To get you on the internet more quickly in more places, Wi-Fi Sense automatically connects you to open Wi-Fi hotspots it knows about through crowdsourcing. Of course, this is a usability over security feature. Maybe some of you remember this feature because it was heavily criticized by the community for allowing anyone that gets access to your network to share it with their friends on Facebook or Outlook contacts. So I remember when this feature came out, a lot of people came and say, no, we don't want to share our network. The thing is that this feature, the one that shares your network with your friends, has been removed after an update. However, Wi-Fi Sense hasn't been completely removed. So still, Wi-Fi Sense is going to connect you to some public hotspots that Microsoft considers secure. And this feature is enabled by default on Windows 10 and Windows Phone 8.1. So as you see on the screenshot there are some networks when you're using Windows Network Manager that are tagged as Wi-Fi Sense. These networks are considered safe or actually high quality by Microsoft. And your device is going to connect automatically to it. So this opens a vector. This is something that maybe we can exploit somehow. Let's see what can we do. First of all, let's see how Wi-Fi Sense works behind the scene. What is happening is that every time a Windows device is connecting to an open network, it's going to send some information to Microsoft about its quality. It's going to say, yes, this is a good network. I'm having a good bandwidth here. I'm having fun. Please tag this network as a high quality network. So Microsoft is going to collect this data. And it's going to build a database of high quality networks. This is called the Wi-Fi Sense networks, right? It looks like that Microsoft doesn't store only the name of the network, also known as ESSID, but it also stores the ESSID associated with a location. That means that if you find a free Wi-Fi here that is marked as Wi-Fi Sense, that doesn't mean that every free Wi-Fi in the world is tagged as Wi-Fi Sense, right? So Microsoft makes an association that says, no, in Amsterdam, there is a free Wi-Fi that is close to the airport, for example, and the other free Wi-Fis are not Wi-Fi Sense. And what happens is that Microsoft pushes back to the Windows devices any Wi-Fi Sense tagged networks that are within the area of the user. So that means that not all Windows devices share the same Wi-Fi Sense networks. For example, I am from Greece, I live in Athens. I can see Wi-Fi Sense tagged networks when I open my network manager, but when I went to San Francisco or Dubai, for example, I wasn't able to see any. While people in Dubai with their Windows laptop, they were able to see. So Microsoft is going to push you only networks that are where you live, where you are usually connected from. How can we exploit this feature, right? What we do in Lure 10 attack is first tricking the victim to believe that is within the area of a Wi-Fi Sense network. And we can do that by fooling the Windows location service, by spoofing our location. We want to make the device to believe that it's somewhere else. For example, if I know that there is a Wi-Fi Sense network in the Amsterdam airport, if I want to do the attack to you, I'm going to fool your Windows location service to believe that you are currently in the airport. As soon as I do that, I can pretend I am this Wi-Fi sense network. I can mimic this network. And then you will automatically connect to my access point. And I will get man in the middle that way. We notice that we can simply broadcast the same name, the same ESSID, and that's enough. We will get man in the middle so simple. So how can we fool the Windows location service? Let's see that step first. How it works, how Windows location service works. Windows devices are sending the BSSIDs. The BSSIDs are the MAC addresses of the access points, okay? So it's gonna send the BSSIDs of the nearby access points to a server that is the Microsoft's Wi-Fi positioning system. And this server is gonna take all these MAC addresses and it's gonna say, okay, oh, I see you have this list of MAC addresses where you are. So you probably are in Amsterdam's airport, okay? The thing is that these beacon frames that contain the BSSID are management frames in 802.11. And the management frames are unprotected. So I can easily make my own management frames. It's very trivial. I can put my card in monitor mode and make my own beacon frames. So I can start sending beacon frames to the air here, and I can fool the Windows location service to believe that the user is in Amsterdam's airport. The only thing that I need to do so is send a lot of these frames. And that means that all the applications and services that rely on this for sensitive data, all of these are vulnerable to this threat. And specifically, Wi-Fi Sense, the feature that we try to exploit today. So the first thing that we need to do this attack, to do Lure 10, is to find the right networks, to find some networks that we want to move the victim to this area and then present this network. So this network needs to be, of course, Wi-Fi Sense network, right? In order to do the automatic association. It needs to be in an area that is relatively close to the victim because, as I said to you earlier, not all Wi-Fi Sense networks exist in the same Windows devices. So if someone lives in Amsterdam, I'm gonna look for Wi-Fi Sense networks that exist in Amsterdam, not in Athens. And the third is that I want to find a network that exists in an area with multiple other networks around. This is because the spoofing is gonna play much better that way. It's gonna work much better. Because I will take all these networks, BSSIDs, MAC addresses, and I will broadcast them to the air. There is no public API from Microsoft that returns all the Wi-Fi Sense networks that exist, the geolocation of the Wi-Fi Sense networks. So we're going back toward driving. What we're looking for is mostly public hotspots. The networks that are tagged as Wi-Fi Sense are mostly public hotspots that you can find in airports or coffee shops. Common SSIDs, for example, I'm not sure if you're aware of the phone networks. These are some networks where you actually share some of your network's bandwidth and allows you to connect to these everywhere you encounter them. These are common SSIDs. These are very common to be tagged as Wi-Fi Sense. And there is this feature on Windows Phone, as you see on the screenshot there, that has a button called Map Nearby Wi-Fi. If you click on this, you will see all the free hotspots that are in an area that are supposedly popular hotspots. Okay? We notice that a subset of these networks are Wi-Fi Sense, not all of them though. So as soon as we find a network that is tagged as Wi-Fi Sense, what we need to do is to collect the right data to do the attack. What we need to collect is, first, the MAC addresses, the BSSIDs of the networks that are within the area, and second, the ESSID, the name of the network that is tagged as Wi-Fi sense. We can do that either by going there physically or using an API that returns the data of Wi-Fi hotspots. For example, if you go to wiggle.com, you will find an API like that. So we have everything we need. We have the data, we have the BSSIDs to spoof the victim's location, and we have the SSID. So what we need to do now is to mount our attack, is to go close to the victim, and we're gonna send 3 kind of frames, okay? First, we're gonna send beacon frames with the MAC addresses that we got to fool the location service. This is gonna spoof the location, and what is interesting is that we can put, when we craft these beacon frames, we can put the ESSID equal to null. This is gonna make, because if we send beacon frames with random names, the victim, for example, may have a look to his network manager and he's gonna see a lot of networks that say, oh, these networks didn't exist here before. But if I put them to null, then I will have my networks hidden, and still I will be able to spoof, to fool the location service. That's number 1. Number 2 is I will send the authentication frames. These are also management frames. There's also no encryption, no signatures, no authentication there, so I can just craft the auth frames. The auth frames will help me in the case that the victim is already associated with the network. For example, the victim is already connected to his home network, and I want him to kick him out of this network so he can connect to my network. So I'm gonna send the auth frames for that. And finally, I'm gonna send beacon frames again, this time with the ESSID of the Wi-Fi sense tagged network. And the victim is gonna believe that this Wi-Fi sense network, since it's in the right position, in the right location, and it's gonna connect to it automatically. This is how the automatic wireless association algorithm on Windows 10 looks like. At first, the client is not connected to any network. It builds the list of all the networks that exist in the area. It scans for all the networks by taking the beacon frames in the air. And then it will go through the PNL, the preferred networks, the networks that has associated to in the past. If it encounters a network that has connected to in the past, it will connect to this network. If not, it will go to the second loop, where it's gonna send for Wi-Fi sense networks. If there is a Wi-Fi sense network in the area, it will connect to this network. That means, let's see an example. Let's say that the networks that exist in the air are the list that you see, the ANL. There's the Unilabs, then there's an airport 3, and 3 more networks. Let's say that this device that we're targeting also has some stored Wi-Fi sense networks, 3 specifically. And this device also has the PNL. This device has also connected in the past to 2 Wi-Fi networks. So as you see there, the networks that are around, there is the airport 3, and the airport 3 is also a Wi-Fi sense network. And there is no network that is close to the victim that is also in the preferred network list that has connected to in the past. So that means that the victim device is going to connect automatically to the airport 3 network. However, in case 2, this time we have the My Home Wi-Fi that is also in the preferred network list. So in that case, the device will prefer, it will go to the first loop there, and it's going to prefer the My Home Wi-Fi network instead. What can we do in case 2? We have a number of options. So what we need to do is remove this network from the available network list, from the ANL. We can do that either by mounting a denial of service attack on the wireless router. For example, a way to do that is to send multiple authentication requests. There are some, because the router needs to hold all these authentication requests in memory, there are some routers that freeze for some seconds. This is enough for us for making the device to connect automatically to the Wi-Fi Sense network. Or the option 2 that is also working is to launch a physical layer jamming and actually destroy, disable the reception of all the beacon frames and all the probe response frames. So what we want to try and what we're achieving with these two methods is to disappear these networks from the ANL. I want you to show the attack. So I have a video. Let's see. Let's go right there. Okay. Let's see how it works. So what you see there is this is the victim, okay? And we made the victim open the maps so we can see the spoofing, the location service spoofing. So right there, the victim is somewhere in the center of Athens. And as soon as we mount our attack, it goes somewhere else, okay? The location service was spoofed. So we will open the network manager now. Okay, as you see there are some networks, ASDF something. These are not real networks. No one can connect to these networks. These are our custom beacon frames, okay, that we have set and we have put the BSSID, the MAC address to spoof the Windows location service. These are not real networks. We just made them to spoof the location service. We could put the ESSID as null, and this wouldn't appear there, and the location service would be fooled either way. And there is also, you see on the top, there is a Wi-Fi Sense network that we also broadcasted that exists in this new area that we teleported the victim to. So let's see what's going to happen. So you see there's a little, the Windows location service fooling is not, maybe it's not going to work that well. Maybe the victim is going to go back, but that doesn't affect our attack. The network is still marked as Wi-Fi Sense. There you go, connected. And that's a very trivial way for getting man in the middle on Windows. I'm glad you liked it. So, this covers up the whole attack. So you see let me make this full screen. Okay. So the attacker is top right, the evil guy, and is sending these three kind of frames that we talked about. First of all, the deauth frames to disassociate the victim with the current network that is associated to, with the access point, as you see the one in blue. Secondly, the beacon frames to spoof the location of the victim. So you see the AP1, AP2, AP3, these are not real networks. So we fool the victim is gonna send these BSSIDs to the WPS, to the Wi-Fi positioning system, and the Wi-Fi positioning system is gonna return back a location, but this location is not gonna be the real location. And finally, we're sending beacon frames with SSID equal to the Wi-Fi Sense network that exists in the area that we moved the victim. And we're going to get the man-in-the-middle position that way. So we disclosed this to Microsoft. We emailed Microsoft about this issue, and this was the response. Basically, they're saying that they didn't know that about the ability to fake the location. That was new for them. However, they considered this an accepted risk. They're not planning to release a patch anytime soon. Am I affected? Yes, you are, if you're using a Windows 10 or Windows Phone 8.1 with the default settings. If you set up your system using the Express settings and you click next, 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 you are vulnerable. How can you protect yourself? Symbol, disable this feature. You go to settings, Wi-Fi sense. You need to make sure that the connect to suggested open hotspot is turned off. I am the author of Wi-Fi Fisher. Wi-Fi Fisher is an open source rogue access point tool. If you go to wififisher.org, you will find more information about it if you don't know about the tool. So version 1.3 of the tool is going to be released today, okay? And it's gonna feature this technique. There are options in the new version that you can capture an area. You can capture the MAC addresses of an area. And then if you go to the victim, there's another option that you can do to mount the attack, to fool the location service, to spawn a Wi-Fi sense network, and get a man-in-the-middle position that way. And that was all by me. Thank you very much.
Thank you very much.
There's some time for questions, I think. So.
Yeah, a lot of things I heard for the first time today. I'm not very familiar with this technology, but could you explain again how the de-authentication works? That apparently is also...
The de-authentication?
Yeah.
So yes, in 802.11, let's make it, okay. In 802.11, which is actually the protocol that defines all the Wi-Fi magic, there are the so-called de-auth frames. These are messages whenever your client wants to disconnect from a Wi-Fi, he's gonna send this and say, hey, access point, I need to go somewhere else now, so I need to disconnect. Also, there are some de-auth frames from the access point to the client, when the access point wants to reboot, for example, or needs to do a firmware upgrade. And again, the access point is gonna send to the clients, please de-authenticate, I need to do a firmware upgrade. The thing is that these messages are not protected by cryptography. So anybody can take these messages and spoof them, pretend that it's the client or pretend that it's the access point, sends them to the air, and do this kind of attack, a denial of service attack, the authentication. These are pretty trivial attacks. There are many tools that do this kind of attack. Wi-Fi Fisher does this attack since version 1, also MDK3, and it's very trivial. It works in most setups.
Very clear. Thank you.
No problem.
More questions?
Yes.
Is this actually on? Yeah. How does Microsoft determine which users get the Wi-Fi enabled, the trusted network segments? How does it differentiate that you will only see a subset of that overall list? And secondly, is the entire list available for anybody to get hold of? As in all identified trusted
If I understood the first question, is how Microsoft determines which networks to send to which device, which Wi-Fi sends? Okay. Every Windows 10 device or Windows Phone 8.1 device has a list of Wi-Fi sense networks, all of these devices. Since the Wi-Fi sense feature is enabled, they have some Wi-Fi sense network stored. It has to do with the area that you are. So as I said, if I am in Athens, I'm definitely going to see a lot of Wi-Fi sense networks in Athens. However, if I move to San Francisco, we noticed that we weren't able to see any. Maybe after a while, Microsoft is going to send some to us. But I don't know. I was in Dubai. I was in San Francisco for a week, and still I wasn't able to see any Wi-Fi sense networks. However, people that are in San Francisco were able to see Wi-Fi sense networks. So it has to do with the location, and apparently Microsoft sends the networks of your country or something like that, or your city, something like that. And can you tell again question number 2, please?
I basically wanted that entire list, but I think you've kind of answered it. I guess if you just move people around locations,
exactly,
and then eventually you'll hit a hotspot. I'd be interested in how they're differentiating the fact that you don't see any sense networks when you move to San Francisco. What is it that separates your client from my client?
I believe Microsoft probably holds, Microsoft knows where you live, right? Microsoft probably knows where you live, so it knows that you are somewhere in Athens, for example, because you have a lot of connections from Athens. So that's probably how it is. Maybe after a while, when you go to San Francisco, after a while, it's going to realize that you moved, and it's going to send you these networks as well.
It makes sense that there's no API, I guess. That's
Yeah.
Okay, got
Thank
one
you.
more question here before we go into the coffee break.
So you said it's you're using the SSIDs to fake the location. Do they not make any use of GPS at the same time, like to?
Oh, that's a valid question. So if you are using a GPS, this is not the Windows location service. The Windows location service relies specifically on the BSSIDs that are around. The GPS is another thing. The GPS is going to use the GPS as usual.
No, I'm saying, why don't they just combo the data together and go, oh, well, you couldn't possibly be at the airport because you're 5 miles away.
No, the thing is that the GPS is going to consume a lot of battery to the device. So all Windows phones and Windows devices don't have GPS enabled by default. You need to manually set it on. However, the Windows location service doesn't require any heavy battery consumption. So it's enabled by default all the time. And it's working in this way. You just get the networks around, you send them to the position server, and you're getting back the position.
Thanks.
Sure.
Okay, if you've got any more questions, you can maybe now use the coffee break to ask them. We'll be back here in half an hour, and there's 2 more talks. So if you really want to be an expert after this day in how communication can be intercepted and misused, then please come back in half an hour when we've got 2 more talks.